Hello students, in this video part 2, we will discuss physics topics for the preparation for the end of term exam 2024-25. So let us begin. So the first topic is speed, and the speed is actually the distance covered in unit time. Unit time is 1 second or 1 hour. So I repeat, speed is nothing but simply it's a distance covered in unit time. The letter used for speed is S, and the SI unit, which is international unit, is meter per second for speed. Because for distance the unit is meter, and for time the unit is second, so the unit of speed becomes meter per second. This slash is for you, we call it per. It means every second. So speed is distance covered in every second. Here is the speed's equation. S equals d over we use for calculating speed, distance, and time according to the question. Let us have an example of speed to better understand. Let us see one car which is covering a distance of 300 centimeters. I repeat, 300 centimeter in 3 seconds. So if I ask you how many centimeters in 1 second, so the answer is 100 centimeter in 1 second. And students, this is exactly we call speed. Speed is the distance covered in 1 second. So 100 centimeter is the distance covered in 1 second. So that's why we call this number is as a speed of the car, 100 centimeter per second. What are the other units of speed? So we see in the cars kilometer per hour, miles per hour, and somewhere centimeter per second. Now this triangle, for just make it easy, memorize the formula for speed. You can see this triangle as d here at the top, distance is at the top, and speed at the left side, and t is the right side. So when we need speed, we just cover speed, what we are having left with. So d and t are we having, so d divided by time. For distance, it is let's cover the d. We are having s and t only, so this will be multiplied. We get distance. I put this mark of division here. Put this multiplication mark. Time, and we are left. Let us test. Letter S is used to write speed. International unit for speed, but the distance covered in unit time. Here is a problem. These questions will come in the exam, probably, possibly. So in this question, it's you need to find the speed of a football that moves 34 meters in 2 seconds. So here is the solution. Distance and time is given in this question. Distance d 34 meter, time 2 seconds. So we need to find speed equals question mark, which indicates that you need to find speed. Now the formula is S equals d over t, which is 34 divided by 2 gives 17 meter per second. A driver makes a trip which is 2,380 kilometers in 28 hours. What is the driver's average speed? So given numbers are a distance d 2,380 kilometer and the time 28 hours. What to find is average speed. Average speed is the total distance divided by total time. When we call average speed, when the speeds may change, sometimes you see the on the road there are traffic, there you go sometimes faster, sometimes slower. So what is the average speed? So we need this one, total distance over total time. So this is 2380 divided by 28, which gives you 81 kilometers. This is different question, different category. How long would it take a bus traveling at 52 kilometer per hour to travel 130 kilometers? So the distance and speed are given in this question. Distance 130 kilometer and speed 52 kilometer per hour. What we need to find is time. How long, which is time. So time equals d divided by s, and you get the answer. Now, this topic is also important for the exam, and the topic is Newton's third law. Newton's gave three laws actually: first law, second law, and third law. So, third law of Newton is coming in the exam. So, this is actually about two forces. You apply a force on a box. Suppose your force is 5 Newton, maybe we can say F2, and the box is also applying a same equal force 5 Newton, but in the opposite direction. See, we can say F1 is by the box to you and F2 is on the box by you. So Newton's third law says that both forces are equal and opposite. We call it action and reaction. This force action and this force is reaction. Now, in other words, we can write here F1 is equal to C equal to opposite actually. Minus indicates opposite direction. If F1 is right side, F2 will be left side. F1 is eastward, F2 will be westward. Like this. F1 will be upward, F2 will be downward. So always it is opposite directions. Now this graph, distance time graph is important. We have a question. We need to explain the motion of this elevator. This distance time graph is for an elevator. We need to explain the motion of the elevator. For from the graph to make it easy understandable. So time, we start from 0, 1, 2, 3, 4, 5. 0, 1, 2. Distance, we have 2, 4, 6. See, when the time is 0, distance is 10. I write here distance as height because actually this is elevator which is coming from the. So when we started the stopwatch, which is, it was at 10-meter height, and you can see 10 meter 0 minute. At 1 minute, you can see the elevator is reaching here at 6 meter at 1 minute, and at 2 minute the elevator is at the 6 meter only. 1 minute 6 meter, 2 minutes 6 meter. So this is very interesting and very important to know and learn. For examination point of view, in exam these types of questions are coming, like you see this line, this portion is the parallel to this time axis. So whenever you see anything parallel with the time axis, it means the object is not moving. You can say that the time is running, but the distance is not running, distance is not changing. Distance is 6 here, 6 here. So now at next minute, when the time is 3 minutes, the elevator is coming down at 2 meters, and in the next 1 minute it remains there, it stops there. Might be people are coming out of the elevator, some people are entering in the elevator, but it stays there for 1 whole minute. And then at 4 minute it is 2 meter, and then at the end of the 5 minute the elevator is at 0 meter on the ground floor. Explanation. So it starts from height of 10 meter and coming down, stays there for another 1 minute. At 3 minutes, it comes at 2 meter. Well, I have the explanation here, which we discussed already. Now another question, similar question. A driver travels 55 kilometer in 1 hour. He then drives at a speed of 35 kilometer per hour for 2 hours. Next, he drives 175 kilometer in 3 hours. What was his average speed? You can see the speed is changing. There are three different speeds because of the three different times and distances. So we write the given first. D1, distance 1, 55 kilometer. T1, 1 hour. D2, here speed and time. 35 times 2, 70 kilometer. D2 is 2 hour. D3 is the speed is total distance over total time. 55 plus 70 plus 175. 180, it is 300 divided by 3566, which is 50 kilometer per hour. Now another topic is friction. Friction helps to walk comfortably. If there is less friction, we might slip. There will be more speed, more motion, and more friction reduces the motion. Uh, Here is a question related to friction. When you run, your feet are pushing you forward. You push the earth backward and you move forward. Friction keeps your foot in contact with the ground. According to Newton's third law, you are pushing the ground back. Explain why earth is not changing its motion. So, according to Newton's third law, we push the ground, ground is pushing us. But the earth is not changing its motion because it's very, very massive than you, than us. Okay, so that's why there is not effect of the motion on the motion of the earth. Although there is Newton's third law, which says action, every action has equal and opposite reaction. Gravity and its factors are the next topic, which is important for this exam. Gravity is a force actually which is attracting everything towards each other. For example, everything near the earth is falling towards the earth because of the gravity. What are the factors for the gravity? So the mass is one factor. Distance is another one. More mass cause more gravity. This is called directly proportional relationship. So Earth has Earth has gravity, more gravity than the Moon, because the mass of the Earth is more than the mass of the Moon. But Jupiter has even more gravity than the Earth, because Jupiter has more mass. So you increase the mass, the gravity will increase. Now let's talk about distance. More distance, opposite happens, less gravity. This is easily understood that see, the uh, an astronaut in the space feels very less gravity because he is away from the earth or from the moon. But you are on the earth, you feel more gravity. You feel more gravitational force. That's why you jump and that astronaut jumps maybe 3 4 times he jumps 6 times higher than you here on the earth because so because moon has the less gravity because the mass of the moon is less, but here we were talking about distance. So more distance, less gravity. Standing 5 meters apart is more than gravity between two men standing at the same distance. So the gravity between the elephants will be more because their masses are more than the men. Now the gravity between them when they are 5 meters apart. So you see here the distance reduces, so the gravity becomes more here. Here it is less because the distance is 10 meters. Here is an interesting question. Earth, moon, an astronaut moving towards the moon. So the gravitational force between the earth and the astronaut will decrease because he is moving away from the earth and reaching towards the moon. Now the gravitational force between moon and the astronaut will increase. how can you describe the position and motion of the train outside the window? So see, if a passenger is sitting inside the train, for him, position of the train is not changing. Position of the train from inside is not changing, and train from inside is not in motion. But when we talk outside of the window, which is outside of the train, so the position of the train keeps on changing, and so the motion is also, the train will be in the motion. In this question, there is east as a reference. You can see the east is facing towards the right. Abdurrahman, a boy, moves from the bus stop to the museum. We need to find whether his direction is positive or negative. So, yes, his direction is positive because he is moving towards the east. In this example, what is the total distance we need to find? Total distance covered by the player from points A to D, D to C, C to B. You can see the path is not a straight line. Path is keeps on changing. So the distance is actual path length. So the distance is A to D, A to D 10 meter plus D to C 41.2 plus C to B 10, total 61.2 meter. Now the displacement from A to B is, students, displacement is always in the straight line, and displacement is always the shortest distance, shortest. No matter where you have taken that path or not, but displacement is always the shortest path, not maybe actual path. Okay, so displacement is 10 plus 40. 50. Here is an interesting graph related to the motion of this turtle. This is the distance time graph. We need to find the speed of this turtle. Speed we need to find from day 0 to day 2. This is day 0, and at 0 the distance was also 0. At day 2, how much is the distance? 10 kilometer. So speed formula is distance over time. So distance 10 and time is 2, which is 5 kilometer per day. Day 2 to day 3. Day 2, the turtle was at 10 kilometer. How much distance it traveled in 2 days? From 10 kilometer to 12 kilometer. 2 kilometer only. It has covered 2 kilometer in from day 2 to day 3, which is 1 day. So 2 is the kilometer, 1 is the day, 2 kilometer per day. Now from day 3 to day 4. Day 3, turtle was at 12 kilometer. Day 4, you remember the previous graph has a similar structure, parallel. It means the turtle is not moving. From day 3 to day 4, turtle has been at the same kilometer, 12, 12. So 0 kilometer is the distance. Because from 12 to 12, 0 kilometer. He is not moving, he is sleeping, might be. He has decided. I told you before that anything like this, it means the object is not moving, stationary. Now from day 4 to day 6, day 4, 12 kilometer, day 6, 24 kilometer. How much total? 24 minus 12. Because at day 4 he was at 12 kilometers, and day 6 he was at 24 kilometers. So how many net kilometers he has traveled in this period? 24 minus 12, only this much, 12 kilometers. 2 days, 2 days, 6 kilometer per day is the speed. Now here is acceleration equation. Acceleration equals force divided by mass. Acceleration unit is meter per second squared. Force is Newton. Mass unit is kg. We have a triangle for this equation as well. FMA. If we need F, we cover this. We multiply M and A. If we need M, we cover M. We divide F by A. If we need A, we cover A. We divide F by M. Here is a question. There is a force of 100 Newton. So you see the acceleration 2 meter per second square, and force is 100 Newton. So what is the mass of the object? Given numbers are force 100 Newton, acceleration 2 meter per second squared. We need to find M, mass. The formula is M equals to force divided by A, 100 divided by 2, which is 50 kg. Another question, we have force 2.0 Newton and a mass 0.60 kg. We need to find acceleration. So F equals 2 Newton, mass is 0.60 kg, acceleration formula is force divided by M, which is 2 divided by 0.60, 3.3 meter per second squared. Thank you for watching.